Picture this. It is 2012. A major financial services firm called Knight Capital Group updates their trading software.
Oh, boy. I know where this is going.
Yeah, it's a nightmare. It's supposed to be a routine update, just, pushing some new code to their live servers. But within minutes, something goes catastrophically wrong.
Right. The system just completely goes rogue.
Exactly. The software starts buying and selling millions of shares erratically. Alarms are going off, panicky engineers are scrambling, but they literally can't figure out how to stop it.
Which is terrifying for anyone in tech.
So terrifying. By the time they finally shut the system down, like 45 minutes later, the company has lost $440 million.
Wow.
45 minutes, $440 million. And, it all came down to a flaw in their quality assurance process. They just hadn't properly tested how the new code would interact with this obsolete piece of code left on their servers.
It's such a crazy story. But I mean, it perfectly highlights a reality that most of us just ignore every day. We tap our screens, and we just expect our digital world to function effortlessly.
Oh, totally. We take it for granted.
We really do.
Yeah.
But underneath that glass, there's this massive invisible infrastructure of really rigorous, almost scientific methodology that's specifically designed to prevent those exact kinds of disasters.
Which brings us to our mission for this deep dive. Whether you are a college student wondering how tech actually gets built, or a fresh graduate hitting the job market, or, just an office professional who has absolutely zero QA experience, we are pulling back the curtain today.
Yes, we are looking at the document titled Anatomy of a Test Case.
Right. We're exploring this foundational tool of software testing. And by the end of this, you're going to understand exactly how professional QA engineers build these safety nets from the ground up.
I'd argue it is the single most important artifact a QA tester will ever produce. Because, writing a test case isn't just about clicking around an app to see if it breaks.
Right. It's not just messing around.
Exactly. It's about creating a repeatable, airtight diagnostic tool.
Okay, let's ground this with an analogy right out of the gate. Think about baking. In the software world, we have 3 terms that get thrown around a lot. There's a test scenario, a test case, and a bug report.
Okay, the baking analogy is perfect for this.
Right. So if we are testing a cake, a test scenario is really just a high-level idea. It's you standing in the kitchen saying, hey, let's bake a chocolate cake today.
Right. It's a concept. I mean, it gives you a general direction, but absolutely zero details on how to actually get there.
Exactly. And then on the total opposite end, you have the bug report. That's you taking a bite of the finished cake and just spitting it out because you used salt instead of sugar.
The worst surprise.
The bug report is the evidence of a terrible outcome. It failed. But the test case, that sits right in the middle.
Yeah, right between the idea and the failure.
Yep. The test case is the exact step-by-step recipe. It's the comprehensive list of ingredients, the precise oven temperature, the exact mixing times. It's a document so incredibly detailed that anyone, literally anyone, can walk into that kitchen and bake the exact same cake every single time.
And that distinction is just so critical. A test case, it operationalizes a vague idea into an executable set of conditions, inputs, and steps.
Okay, that makes sense.
And, the most important part of that definition is that it has to be written in advance. If you don't have that rigid recipe structure, your testing just, it devolves into personal notes.
Like just writing down, click here, try this, see if it works.
Exactly. And those notes might make sense to you on a Tuesday when you're in the zone, but they are completely useless to a teammate or to a brand new hire.
Or even to yourself 6 months later when you've forgotten what you were doing.
Oh, 100%. So without structure, it's just chaos.
So how do we actually construct this recipe? What does a professional test case actually look like? Well, we have this incredible source document today, and it outlines 12 universal building blocks used across the industry.
Yeah, and it doesn't matter if you're using heavy-duty enterprise software like TestRail or Zephyr or just a well-organized Excel spreadsheet. These blocks apply.
Right. So let's break this down into 3 distinct phases to make it easy. The setup phase, the action phase, and the verdict phase.
Let's start with the setup phase. This is basically everything that happens before you even touch the software. It includes your ID, your title, the module you are testing, and your preconditions.
The ID is pretty self-explanatory, right? Something like TC login 004, just a tracking number.
Yep, just an index.
But the title is where I see a lot of room for error. Like, a bad title would just be, test login.
Oh, test login is a complete disaster. It tells the reader absolutely nothing. The rule of thumb for a great title is that it must be one precise sentence. Two different testers should be able to read just the title and end up testing the exact same thing.
So instead of test login, it should be something like verify user can log in with a valid email and correct password.
Exactly. That leaves zero room for misinterpretation. And right after the title, we hit preconditions.
Okay, so going back to our baking analogy, this isn't the first step of the recipe. This is making sure you actually have flour in the pantry and that the oven is preheated before you even start mixing.
That's a great way to put it. Preconditions define the state the system must be in before step one, and they are not optional. They are a strict contract.
Good contract.
Okay, like you can't write a test step that says click the delete button if you haven't established what is actually being deleted in your preconditions. If you do that, your test case is fundamentally broken.
Right, because there's nothing there to delete.
Exactly. So for a login test, a precondition might be user is currently logged out or user has a verified account. If you skip this, two testers will start from entirely different system states and get completely different results.
I can definitely see how that prevents absolute chaos. So the oven is preheated, the ingredients are on the counter. Now we move to phase two, the action phase.
This is where things get really practical.
Right. This involves the test steps and the test data. And the standard here is to use what are called atomic test steps, meaning one action per step.
Yes. You should never, ever bundle things together.
Like saying, enter your email, password, and click login all in one step.
Right. Bundling is a huge temptation because it just feels faster to write. But think about what happens when the test fails.
Yeah.
If you bundled those three actions into step two and step two fails, which action broke?
Oh, wow. Yeah. Did the email field reject it, or did the password field freeze, or is the login button completely dead?
Exactly. You have no idea.
It's like the cake again. If my recipe step is mix the flour, sugar, and baking soda, and the cake doesn't rise, I have no idea which ingredient was expired. I have to isolate them.
Precisely. Atomic steps, doing exactly one thing per step, isolate the point of failure. And notice how professional frameworks separate the test steps from the test data.
Yeah, I saw that in the guide. You don't write enterjohndoe@gmail.com in the step itself?
No, the step is just enter email address. The data field next to it is where you put johndoe@gmail.com.
That's incredibly smart because now I can reuse those exact same steps over and over, right? Just swapping out the test data to see what happens when I use a weirdly formatted email or a password that's way too short.
Exactly. It creates a highly modular, reusable testing framework. And a quick note on the language used in these steps. It has to be imperative and precise. You write in the present tense, like enter email, not the user enters their email.
Got it. And the terminology has to match the hardware, right? Like you say, tap for mobile devices and click for desktop.
Yes. And perhaps the biggest language rule in the action phase. You never use the word observe as an action step.
Wait, really? That is fascinating. Why ban the word observe? I feel like I'd use that a lot.
Because observation is an outcome. It's not an action. You perform an action to trigger something you can observe.
Oh, that makes sense.
It's a subtle psychological shift, but it really forces the tester to focus on what they're actually doing to the system rather than just passively watching it.
Which transitions us perfectly into phase three, the verdict phase. The actions have been taken, and now we need to know if the software survived.
The moment of truth.
Right. This phase includes the expected result, the actual result, the pass-fail status, priority, severity, the test environment, and the traceability link.
That is a lot of blocks, but they all serve a purpose.
Let's tackle the most crucial one first, expected results. The rule is that vague phrases like, it should work, are just totally banned.
Oh, it should work is the absolute enemy of quality assurance. I mean, what does work actually mean?
Yeah, to me, it might just mean the page doesn't crash.
Right. But to a designer, it might mean a specific animation plays perfectly. You need a completely observable expected result.
So instead of it should work, you'd write something like, the user is redirected to the dashboard and a welcome back toast notification appears within 2 seconds.
Yes, that is perfect.
And real quick, for anyone unfamiliar, a toast notification is just that little pop-up message that slides in at the bottom of your screen. It kind of looks like a piece of toast popping out of a toaster.
Exactly. And when you are that specific in your expected result, there is zero argument over whether the test passed or failed.
Now, I want to wrestle with a concept that comes up in this phase, because honestly, reading through the source material, this tripped me up. Priority versus severity.
Oh, you are not alone.
Because on the surface, those sound like the exact same thing. If a bug is a critical severity, doesn't that inherently make it a high priority?
It is easily the most common point of confusion in the entire industry. but they answer two entirely different questions.
Okay, lay it on me.
Severity is a technical measurement. It answers, how badly is the system physically broken? Priority, on the other hand, is a business decision. It answers, how fast do we need to fix this?
Okay, let me test my understanding on this, because I really want to make sure I've actually got it. Let's say I'm testing a massive open-world video game,
Okay, I'm with you.
and I find a bug where if you stand in a highly specific, totally hidden corner of the map that almost no player will ever find, the game just completely crashes and your console restarts.
A total crash.
Right. Technically, a total system crash is a critical severity, right? The system is completely broken.
Correct. The severity is absolutely critical.
But because it's in a hidden corner that like 99% of players will never see, the business folks might say, look, we have way more pressing things to fix before launch. We'll patch that hidden corner next month. So the priority is actually low.
You absolutely nailed it. It's about the blast radius versus the business impact.
Okay, that clicks.
Let's flip it, just to be sure. Imagine your banking app's homepage have a typo in the company logo.
Oh, no.
Right. Technically, everything works fine. The database is totally secure. Transactions go through normally. The severity is incredibly low. Nothing is broken.
But the priority.
Oh, that is critically high because the CEO is going to absolutely lose their mind if the brand looks unprofessional in the App Store.
Exactly. Priority is for the business. Severity is for the technical impact.
I love that distinction. That clears it up completely. Let's touch on two more crucial blocks in the verdict phase: the traceability link and the test environment. What is the traceability link actually doing?
Well, a traceability link connects your specific test case back to a broader business requirement or like a user story.
Okay, so proving why you're doing it.
Yeah, it proves to the project managers that you didn't just invent tests for the fun of it. You are actually testing the specific features the client paid for. It bridges the gap between the technical testers and the business analysts. That's smart. And finally, the test environment. This means documenting the specific operating system, the browser, the device, and the exact build number, which is basically a timestamp version of the code that you tested on.
Oh, and this one is so important. If you skip the environment field, you invite the absolute most dreaded excuse in all of software development.
Which is?
Well, it works on my machine.
Oh, man.
Right. If a developer can't replicate your exact environment, your test case loses all of its diagnostic power.
Okay, let's pull all these theoretical phases together. I want to walk through a real-life scenario that every single listener interacts with probably every day: a login screen.
Let's do it.
Let's say we are writing a test case to make sure a security feature works. Our title is Verify User Cannot Log In with Correct Email and Incorrect Password.
Precise and single purpose.
Awesome. Preconditions. The user has an active verified account and the user is currently on the login page, completely logged out.
Stage is set.
Moving to phase 2, the action. Step 1. Enter email. The data is qauser@demo.com. Step 2. Enter incorrect password. The data is wrongpass99. Step 3. Click the login button.
Those are perfectly atomic steps. Notice how we didn't bundle them up into one messy sentence.
Right, kept them separate. And now phase 3, the verdict. Expected result. The login is rejected. An inline error reading incorrect email or password appears in red. The user is not redirected and no session token is created.
Which is very observable.
Exactly. And just a quick side note, a session token is basically just the digital wristband the server gives your browser to prove you're on the VIP list and actually logged in.
Great analogy.
Thanks. So priority is high, severity is critical, because a failure here means unauthorized people can just access accounts.
Absolutely.
And finally, the environment is Windows 11, Chrome browser, build version 2.4.1.
When you lay it out like that, I mean, it is an airtight document. You can hand that to someone on their very first day of work, and they could execute it without asking a single clarifying question.
Which brings us to the ultimate goal of all this meticulous detail. It all boils down to one word: repeatability. You want to run that test twice by two completely different people on 2 different days and get the exact same verdict.
Because repeatability is the entire foundation of regression testing.
And regression testing is just checking the old stuff when new stuff gets added, right?
Exactly. When developers add new code, you have to run all the old tests again just to make sure the new stuff didn't break anything. If your tests aren't repeatable, you just can't trust your regression testing. You are flying blind.
But achieving that repeatability requires dodging some massive psychological traps. And the source material pointed out a common mistake that fascinated me. writing your expected results after you've already run the test and seen what happened.
Oh, this is such a subtle but incredibly dangerous trap.
Yeah.
And it is entirely based on human nature.
Oh, so?
Well, let's say you write your steps, but you leave the expected result blank. You run the test. The software does something, like slightly weird.
Right.
Maybe the screen flashes white for a split second before logging you in, but it mostly works.
Okay.
Your brain will quietly bias your expected result to just accept that weird flashing behavior as totally normal. You'll literally type out, user is logged in after a brief flash.
So you basically just normalize the bug.
Exactly. You just accepted broken behavior. By writing the expected result in advance, you create an objective, immovable standard. It's a line in the sand that protects you from your own hindsight bias.
It's like writing the law before the trial happens. You can't change it during the case.
That is exactly what it is.
Another common mistake mentioned is merging multiple root issues into one test case. So say you're testing a checkout page and you notice the tax calculation is completely wrong, the product image is a broken link, and the submit button is the wrong color.
A total mess.
Right. So the amateur move is writing one big bug report that just says checkout page is a mess.
Which is an absolute nightmare for developers. The database engineer cannot fix the button color, and the front-end designer can't fix the tax math. You have to keep them separate.
One failure, one test case, one report.
That's the golden rule.
So zooming out from the technical weeds for a second, let's talk about the listener who wants to actually use this knowledge right now. How does mastering this exact anatomy build a career? Because this isn't just academic theory for passing some computer science exam.
Oh, not at all. It is highly, highly practical. If you are trying to break into freelance QA work on platforms like Upwork or Test.io, mastering this structure is basically your golden ticket.
Let's role play that for a second.
Yeah.
If I'm a listener trying to land my very first freelance client, most people would probably just message a startup and say, hey, I'm a QA tester, I can test your app.
Right, and that is so easy to ignore. They get 10 of those messages a day.
But if you use this anatomy...
Right, I go to their live public website, I find a bug. And instead of just saying, hey, your site is broken, I write a flawless 12-block test case.
Yes. I message the founder on LinkedIn and say, hey, I was browsing your site. I noticed your checkout drops carts if the user switches from Wi-Fi to cellular data. Here is a reproducible, step-by-step diagnostic on exactly how to see it happen, complete with preconditions and atomic steps.
It completely shifts the power dynamic.
Yeah.
You aren't just a user complaining anymore. You are a professional presenting a flawless diagnostic report. You are literally solving their problem before they even hire you.
That is amazing.
The key takeaway here is that the anatomy of a test case isn't really about finding glitches in software. It is the anatomy of professional credibility.
That is a phenomenal way to look at it. Let's summarize what we've unpacked today. Writing high-quality, repeatable test cases is one of the most valuable foundational skills any QA engineer or really anyone in tech can develop.
Absolutely.
A test case is not just a to-do list. It is a strict, binding contract between the tester and the reader. It guarantees that the exact same conditions will produce the exact same verdict every single time.
It is the recipe that ensures the cake bakes perfectly, no matter who happens to be standing in the kitchen.
And that contract relies on separating your process into clear phases. Establishing the system state with preconditions, isolating variables with atomic action steps, and banishing vague language to create completely objective expected results.
It takes discipline, but it is so worth it.
Before we wrap up, I want to leave you, our listener, with a final provocative thought to mull over. We've spent this entire deep dive establishing that a test case is ultimately a strict, step-by-step contract designed for perfect, rigid repeatability. But we are rapidly entering an era where AI agents are starting to execute these tests autonomously.
Oh, it is a massive shift, and it raises a critical question about the future of human QA testers.
Exactly. Because as AI takes over the mindless execution of these steps, what happens to the human element? Will the nuances be lost?
Right, like a human tester using their gut instinct to judge the true business severity of an issue.
Or a human noticing a bizarre visual glitch slightly off screen that was never explicitly written in the expected results. Will that human intuition just disappear? Or will humans simply need to evolve into even better, more precise contract writers to manage and direct the AI?
It's a fascinating frontier. The tools we use to execute the tests will definitely change, but the need for a rock-solid logical anatomy to govern those tests, that isn't going anywhere.
Something to think about the next time you tap a button on your phone and the app works flawlessly. There is a meticulously crafted contract behind that tap. Thanks for joining us on this deep dive. We'll catch you next time.